Hello, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Today we are going to continue our journey on thermochemistry and we are learning lesson 44, Arbaun. The title of the lesson is Hess Law. We have to define what is Hess Law, and we have to solve problems using algebraic method and energy cycle method. What is Hess Law? It's when reactants are converted into products, the change of enthalpy would be the same whether the reaction takes place in one step or series of steps. So we would be able to find whatever enthalpy necessary if we have all the others enthalpies. For example, let's look at your figure 1.7. We want to convert P into B. So the enthalpy that is used to convert P into A is delta H1, and after it becomes A, then it would be converted into B, that is using enthalpy of delta H2. That is one pathway. But the second pathway is for it to go through Q first. Maybe it needs a different catalyst, a different condition, so it can go through Q and then through R, and then it would produce B. So we are going to use delta H3, delta H4, delta H5. According to Hess law, you can see the arrow there, the enthalpy change from P to B would be the same, whether it is going through the upper part way or the lower part way. So the upper part would have two reactions, and the lower part would be having 3 reactions. So you can see in the formula down there, we put delta H1 plus delta H2 equals to delta H3 plus delta H4 plus delta H5. It would be the same. So if in any circumstances whereby we want to find delta H3, for example, we are given delta H1, 2, 4, and 5, that is actually possible for us to calculate. Enthalpy changes can be calculated using two methods. Algebraic method is the method that is mostly preferred by students because in every equation that you do, if it's not correct, it would be detected at the end of the process. But for energy cycle method, it involves cycle. So in that particular cycle, even though the equations are all there, sometimes we don't realize there is a bit of a mistake where one equation is not balanced, for example. So the final calculation would be incorrect. Okay, let's learn both of this method and see which one is preferred by your own self. Okay, I will show you how to answer the question. For example, 1.6 using both methods. The question is, find the standard enthalpy of formation of ethane C2H6 given the following data. As you can see, the data is delta HC. It means that carbon is combusted because C stands for combustion. Delta HC for H2. Delta H combustion for ethane. These three data is very critical for us to know how to manipulate. So the first task that we have to do is write the equation. The first equation is C solid plus O2. We know it's O2 because it's going to be combusted. So what are we going to get from this reaction? CO2 gas. The delta H would be negative 393. I will put the unit up here so that it will go for every magnitude in this column. Oops, sorry. Next, we are going to do the combustion for hydrogen. So, hydrogen gas is going to be combusted with excess oxygen, and it is going to produce H2O in the form of liquid, and it is going to be balanced how? It has to be half of O2 over here, and this one is negative 286. Notice that for enthalpy of combustion, the one that is combusted must always be 1 mole. This one must always be 1 mole. Okay, the reactant. So next, we're going to combust ethane, C2H6. This is also in gas form. So we are going to calculate how many oxygen we need later. But we know that the product for this is CO2 and H2O. CO2 in gas form, H2O in liquid form. Right. So how many carbons do we need on the right side here? 2. So we have 4 oxygen. And how many hydrogen do we need here? 6. So we put 3 over here. Therefore, we have 3 plus 4, that is 7 over 2. Yes, you can do this fraction for equation. This one given to you is negative 1560 kilojoule per mole. Now, what does the question want? So sometimes we forgot about that. The enthalpy of formation of ethane. We want to know the enthalpy of formation of ethane. So we need another equation. The equation would be to produce ethane, C2H6. So this must be 1 mole now because it is enthalpy of formation. Now, what are the constituent elements? C, solid. How many? 2 moles plus hydrogen. Hydrogen gas is a diatom. And how much that we need? 3 moles of hydrogen molecule that we need to produce 1 mole of ethane. Okay, the next step here is we want to find 2 carbon. Where can we find 2 carbon? From this equation. So we have to multiply by 2 because we want to get the exact mole with the equation in the enthalpy of formation. So we multiply all of the species in this first equation with 2. So it becomes 2 carbon plus 2 oxygen gas become 2 carbon dioxide. And for the enthalpy also, we have to multiply by 2. And then we are trying to find 3H2. So yes, we can get it from the second equation, whereby we multiply by 3. So we get the 3H2O from the second equation. But here also for O2, we have to multiply by 3. Now it becomes 3 over 2 oxygen gas. and 3H2O liquid. So this one also we have to multiply by 3. The magnitude must be also multiplied by 3 if the equation is multiplied by 3. Okay, now for the third equation, we want to put C2H6 on the right side. But the C2H6 is on the left side. What are we going to do? We can switch or switch the place for the product. Here, we want C2H6 to become the product, this one. But this is actually the reactant. So, we reverse the equation whereby we put CO2 in front. So now C2CO2 is the reactant, 3H2O is the reactant, and C2H6 gas is the product, plus 7/2 oxygen gas. What happens if we reverse this equation? It will affect also the delta H. Can you guess? Yes, well done. For those who guess it right, we are going to switch the sign. The sign previously is negative combustion, and now it becomes a positive, an endothermic reaction. So this is the 3 equations that we derived from the original equation. So we are actually manipulating the equation that we have. Okay. Now we have come to the most interesting part, whereby I want to remove all the unnecessary items in the 3 derived equation. So we have 2C over here, okay, and we have 3H2 over here, and we have C2H6 over here. Everything else must be gone, must be excluded now. So we are going to remove 2 oxygen on the left. If we remove 2 oxygen on the left, we have to remove also 2 oxygen on the right, right? So here is the oxygen on the right. So we remove 2 oxygen from here. So 7/2 minus 4/2. What is left? 3/2 oxygen is left there. Okay, remember. Now, what about CO2? Now, we want to remove this CO2 on the right. If we want to remove these 2 CO2 on the right, we have to find 2 CO2 on the left also. There you go. This is the one that we are doing. Crossing out all the unnecessary element. Okay? Now, next is 3/2 oxygen. Yeah, I think we've got this figure already. 3/2. It's here. So we cross out oxygen altogether. The total of 2 plus 3/2 is basically 7/2. This is your syllabus of mathematics standard 3. Some people sometimes it's hard to get this. Okay. Next, we want to remove 3H2O on the right. So, is there any 3H2O on the left? Yes, there is it. Here is it. And then 7/2 O2. This one is not included anymore. Okay, this one. You can cross this out because it's not included. We have already reversed the equation. What is left now? What is left now is carbon, hydrogen, and C2H6. So we got the final equation of enthalpy of formation of ethane. So it is confirmed that we can now total up all the magnitude of the delta H combustion that we have done. So take your calculator now, and 2 times negative 393 plus 3 times negative 286 plus 1560. What are you going to get? Let's look at the answer in the next slide. Okay. Okay, let's look at the final answer. This is again the derived equation that we have manipulated, whereby the equation of combustion of ethane is reversed, so the sign change into positive. The combustion of carbon is multiplied by 2, and the combustion of hydrogen gas is multiplied by 3. So we are going to get a final answer, negative 84 kilojoules per mole. Okay, so I hope you understand how do we calculate this. Being able to come up with this final answer is a satisfactory process. Sangat berpuas hati if you get this. Congratulations. Okay. Now, the second method would be energy cycle method. Energy cycle method is actually simpler. So, some of the students prefer to use this way. It's just that you have to be careful because every equation in the cycle must be balanced. So, the equation that you have to find would always be on top of the cycle. So the enthalpy of formation of ethane would be at the top. So C solid plus O2 gas, that would produce sorry, this is not O2, this is H2, as much as 3. So C2 H6, this is ethane, and this one is not yet balanced. See? So this is the equation that we want to find the enthalpy. So what is the enthalpy we want to find? That one is here. Okay. So we want to put all the equations together in this, in the form of cycle. So from 2C, okay, we react it with O2, and it will become CO2. So this is gas, and this is gas, and this is not balanced, so we balance it. All right, and the delta H here now is 2 times negative 393. So you're going to have the value here. Right. The second column here, it looks like a column, right? Upper to a lower part. This one, we combust the H2 with O2, and then we are going to get H2O. So if there is no 3 here, it would be easy for us to get 1 over 2 over here. But there is 3 here, so we multiply by 3 with everything here. So the delta H is actually 3 times negative 286. So this is the magnitude. Sorry, tak nampak. 286, negative 286 over there. Okay, so this cycle is not complete yet. You can see there is still one more equation we need to add, but that equation must complete the cycle. So 2CO2 and 3H2O is combined. This is the product of the combustion of C2H6. It is going to be combusted with O2 and it will produce that one. So this is not balanced yet. Let's balance it. 2 CO2, 3 H2O, O2 is 7/2. Okay, 7/2. But this is not actually a cycle because as you can see, let me switch the color first. Okay, this is going there. Okay, and this one is going down. Okay, this one is going down. And these two must be going up. This must be going up. That's it. So, what you have to do is reverse this equation. So, this arrow now will reverse going up. So, what happened is the magnitude will become from negative to positive 1560. So, now you total up 1560, 3 times negative 286, 2 times negative 393, and finally you're going to get the same negative 84 kilojoule per mole. So this is the enthalpy H formation for C2H6 gas. Alright, I hope you understand both of the method. Algebraic method is a bit painful because you have a lot of equation and then you have to write back the equation using the balance number of mole according to the final equation that you want to find the magnitude. But for energy cycle method, it is simpler because the number of mole is clearly stated in the cycle, and all you have to do is just make it balanced and complete and in a cycle. Okay, so that's it. Here is a proper cycle that I'm supposed to show you, but if I show you this at the beginning, you would be able to see how to start. So this is a proper one, typed answer compared to my very scary handwriting. Okay, now let's do example 1.7. This is your chance to do the question first before I explain to you how it's done. So stop the video now and try doing it on your own first. Okay? Okay, the first thing that we're going to do is to write down the equation of combustion according to the data given. So carbon solid plus oxygen gas become CO2 gas. So this is negative 394. The value might change slightly. And then carbon monoxide is gas. It will be combusted with oxygen to form carbon dioxide also. So this one would be only half, right? Negative 283. Now, what do we want to find? Enthalpy change of the formation of carbon monoxide. So carbon monoxide would be the product here. And then the constituent element is carbon solid plus oxygen gas. So this is not yet balanced, so this one has to be half. Now, carbon here is already on the left. Okay, we're going to use this equation as is, but the carbon monoxide here is on the left. We want it to be on the right. So I'm going to reverse the equation. CO2 become gas, CO gas plus half of O2 gas. So they will become positive 283 because the sign will change. Right. So now we have the CO gas at the right. Okay. This one we have, and then this one we have. Okay, now is the process to deduct all the necessary item. So first, we remove O2. So if you want to remove O2 on the left, you have to remove the same amount on the right. But on the right, there is only half of O2. On the left, there is 2/2 of O2. So you are going to remove this, and this one will be left with 1/2. This is the one that is going here. And the CO2 will be cut off here and here. So you can total up -394 with positive 283. The answer is -111 kilojoule per mole. Okay. How are you going to use the energy cycle method? Now, I'm going to use the same equation over here. Excuse me. Okay, because the slide is very small. I'm going to use purple now. So, carbon solid plus oxygen gas becomes CO2 gas. Okay, and then this CO2 is going to go straight away to CO here. So originally CO plus O2 will become CO2, right? So let's have a balanced equation first. C half of O2 becomes CO2. Okay, that is the first one here. Okay, the first equation. And then CO2 dengan CO2. This one is the second one. Okay, the third one. CO plus O2. This one has to have half. Right. So it will become CO2. Now, the thing is, it's not a cycle. Why? Because I use orange now. It go down like this, and then it go down like this. It's supposed to be going down and then going up. So this one must be reverse. So the magnitude here, the value here is -394. Here is positive 283. So you get the answer -111 kilojoule per mole. So it doesn't matter whether you use algebraic method or energy cycle method. As long as it is balanced, you should be able to get the answer. Now, isn't that interesting? When you get the correct answer, you are very motivated now. So proceed with your exercises with practice 1.3, question number 1. The answer is given. Question number 2. The answer is positive 452.8 kilojoule per mole. Please use whatever you can to get the answer. And question number 3 has the answer of -86 kilojoule. So that's it for lesson 44. Thank you very much for watching, and I hope you would do the tutorial questions that I'm going to give after this. Bye. Assalamualaikum.